Hello everybody and welcome to another video and the last chapter of our machine learning course. And in this chapter we're going to talk about something we didn't talk about before. Actually we talked about it but very briefly in the beginning of the course, which is clustering or clustering actually is inside unsupervised learning. We talked a lot about supervised learning, some methods, how to do it, everything, but we never talked about unsupervised learning, which we're gonna do in this video. So let's get started. In this video, we're gonna learn about some notations on unsupervised learning. Then we're gonna see some algorithms, specifically k-means algorithm and the KNN algorithm, or the k nearest neighbors algorithm. So unsupervised learning is finding patterns on a previously given data. So the idea is we are given some x's, some like input data x, but we are not given the y, the labels. Like previously in supervised learning, we were always given the y's, and we train our model to predict the y's for new given data. But at this time, we don't have any previous knowledge about our data. So the solution for that is using what's called clustering. So now we're going to learn about clustering and clustering techniques. So what's clustering? Simply, clustering is trying to put data in groups where they are most likely to be similar. We have this example here. We have here like an unlabeled data, x1, x2, but we know nothing about this data. It's just like scattered data. So our job is try to predict groups for these data points. So you can see here that this bluish green set of data is kind of like separated from other data here, and you can see that here there is some kind of separation here between these two other types of data, as you see here. So we have the bluish, the yellowish, and the reddish data. So that's what we want our clustering algorithms to do, is to separate data according to what's most likely to be together in the same group or cluster. And by the way, this is important thing. We have also most likely in clustering algorithms that we're gonna see, both the k-means and the KNN, you need to provide the number of clusters. For here, we have 3 clusters. That means 3 groups. So let's start with the k-means algorithm. This is our given data, and we want to predict like clusters or groups for this data. So what we're gonna do is I'm gonna explain the algorithm itself. That means this is really important. So what we're gonna do first, we just choose randomly three data points. We call them centroids. These 3 data points we chose randomly, and we call them centroids. Why centroids? Because they're going to be the center of our given clusters. We choose them randomly. Then, after we choose them randomly, we do the cluster assignment step, which is assigning each data point, each one of these, to the closest centroid. So for example, these data points, they are close to the blue centroid, so we assign it to the blue. These data points here, arguably this, so these data points are close to the yellow centroid, and these data points here, the red, are close to the red centroid. So we assign them. So first, we initialize random centroids. Second, we assign the data points, the given data points to the closest centroid. By the way, we choose here 3 centroids. In different situation, we might choose 4, 5, 1, like whatever. It depends on the situation. Then we move the centroids, where we move them to the mean of all clusters, to the mean of all data points. What do we mean by that? We have these data points. We already assigned them to this centroid. This centroid was here, right? Let's go back. Okay, you see, the centroid is here, here, here. So what we do? We calculate the mean. What do we mean by the mean? That means we calculate the position of all these data points, and we divide it by the number of these data points. For example, 1, 2, 3, 4, 5, 6, 7. 7 data points. We divide by 7. We have the average. By the mean, we mean the average. We have the average almost here. If you can almost like see that here. So this centroid, we move it here, and then we calculate the average of this cluster. It's gonna be almost like here. So we move it here, and then this red one, the mean or the average gonna be almost here. So we move it here. The result gonna be like this. After moving. Now, after moving, we do again what's called assignment step. So we assign again all the data points to the closest centroid. Again, we assign them. In this, after this step, in this situation, in this example, we don't need again to iterate again, because if we try to calculate the mean of these, it's almost gonna be the same. Here the same, here the same. So we already have the final centroids. At the final centroids, even if we like try to calculate the mean, the average of data points of each cluster, and put the centroid to the in the middle of that cluster, it's not gonna move because we already are in the average, in the middle. In this example, but in different example, it might be like we need 3, 4 iterations, 5 iterations. We don't know how much. So until we get the final average of our clusters, we keep iterating, and that's how we get the clusters. So you can see here we got the clusters just by moving the centroids every time, and then assigning the data point to the closest centroid, and so on. And in short, that was the k-means algorithm. Now the k-means algorithm. Again, I'm gonna like define it mathematically, more like mathematically, not just by drawings. So the input simply is the number of our clusters and the data x1, x2, x3 until xm. So we have m data points. We have the number of clusters. We choose 3 in our example. It can be any other number. So first, what do we do? This is the algorithm. First, we randomly initialize the k cluster centroids, like we did, C1, C2 until Ck. In our example, we had until C3. That means we initialized 3 random centroids. Then we loop another loop inside. We loop for all our data points, and from 1 to m, that means from x1 to xm, what do we do? The class of the data point I, for example, the class of x1 equals or assign to that class the index of closest centroid to x1. Then we assign the class of x2 the index of closest centroid to x2, and so on. That means for each x we assign its class to the closest centroid. Then after we finish, we loop our centroids. We loop our centroids from 1 to k. In our example, we had from 1 to 3. Each centroid becomes in the average of points assigned. That means in the average of the points we assigned here, the x's, our x's, assigned to cluster J. Here J goes from 1 to the number of clusters. In our example, for example, 3. And like simply that's the k-means algorithm. It's really simple algorithm, and later on when we do it in R, it's gonna be like even simpler to use it. So don't worry about that. Next, the k nearest neighbors algorithm. So this is another algorithm. It's similar to the previous one, but actually I think the KNN is easier. But KNN is sometimes it's considered not unsupervised learning, but semi-supervised learning, because at the beginning you need to know some the class of each data points. We're gonna see the example here. So first, initialize some data to random classes, or initialize them, these data, the magenta data and the yellow data, we initialize them to their own classes, the classes we know before, or random classes, but mostly people use it with their own classes, the known before classes. Then add one data point x and assign it to the group of the nearest neighbor. Then repeat with all data points. Let's see what do we mean by that. So imagine that we have this 1, 2, 3, 4, 5, 5 magenta data points, and 1, 2, 3, 4, 5 yellow data points. So class A, class B. Then we put a new data point, which is this one, the star. After putting this the data point, we need to choose our k. K is the number of neighbors we need to choose before. Don't mix it with the k-means algorithm. We are talking about KNN algorithm. In KNN algorithm, k is the number of neighbors we should see. For example, if we say k equals 3, we see the closest 3 neighbors. In this example, these are the closest 3 neighbors. These are the 3. Then we see there is two data points that are in the class B and one data point in class A. That means we assign this star to class B because there is more data points in class B. Let's see in other situation. For example, we choose because the user chooses the k by himself. Let's say the user chooses the k equals 6. If we say the k equals 6, that means 1, 2, 3, 4, 5, 6. That means 6 neighbors. We see 6 neighbors. If we see 6 neighbors, we calculate there is 2 data points from class B and 4 data points from class A. That means we assign this star to class A because there is more data points close to it from class A. So it really depends on the K. So choosing the K really carefully is really important in the K nearest neighbors algorithm. So simply that was our clustering course. This is the only theoretical course in this chapter. Other videos are going to be practical. So stay tuned and see you next videos.